Hi, everyone. Today we're going to be talking about inference for quantitative data. And we're going to be talking about hypothesis test of one mean, and then also hypothesis test of a difference of two values for the same observations, or mean difference of paired values. And it's really just the same as the test of the mean, except we need some changes in the beginning for that. Content, as usual, coming from this of the slides are coming from the Montana State textbook, Introductory Statistics with R. So let's take a step back and think about statistical inference and actually what we're doing when we're thinking about statistical inference. And the textbook provides these two major questions as of what we're doing here. One, how strong is the evidence of an effect? And then two, how large is the effect? I don't really like how these questions are worded because it gives indication that we're actually looking into a cause and effect. But as we have examined before in this class, we can't really see cause and effect unless we have a kind of experimental setup with treatment and control groups and so on. So what we're really doing here is, one, seeing what is the chance of observing the value at question, assuming a particular distribution. So how likely is for us to observe this particular statistic that we're concerned of, and not how large is the effect, but what is the range of values we could expect. And this is what was going to be the confidence interval. This is going to be the p-value, and this is going to be the confidence interval, which is the range of values we could be confident to get, assuming a particular distribution. And we can actually change our confidence level to manipulate the confidence interval, which is interesting and useful. So thinking about the proportion test, so if you're concerned about a one proportion test, and this is we think of it as a binary categorical data, because even though we're using the term number, 50% or 40% or percentage, which is a number, we're working with categories such as men or women or patients or non-patients, or do they have diabetes or they don't have diabetes, and so on. So these are categorical data, and then we calculate a proportion to plug into our equations and find out these two answers. So let's think of it here in the more specific example that we were working with. Is the proportion of men in the sample of COPD patients much higher or lower than 50%? So the proportion of men in the sample, so proportion of men means men or women, so that's the proportion, in the sample of COPD patients much higher or lower than 50%. And the idea here is that, yes, we want to see maybe a cause relationship. For example, does being man lead to more COPD? And COPD is chronic obstructive pulmonary disease. Does being a man increase your chance to lead to more COPD? And in this sense, yes, we can think about, and we are usually thinking about cause and effect. But when we're thinking of this question here, one, what is the chance of observing the value? The question is, what is the chance of observing this 50%? Or whatever not this 50%, but whatever the proportion of men in the sample is. So let's assume it's 53%. 53% of COPD patients are men, and then the rest are women, let's say 47%. So you may say, well, we already have 53%. That's your statistic. 53% is the proportion of COPD patients that are men, and 53 is higher than 50. So we already have our answer. What else is there to do? Well, the issue is that this is one sample. And because this is one sample, maybe in another sample, it would be 48%. And in another sample, it would be 59%, and so on. So how, given this one sample that we have, how can we know if this value is different enough from what we're comparing with, which is our null hypothesis, the basic 50%? How can we know that whatever value we have, the proportion we have, is different enough so we can say, oh, that seems to be an effect. It looks like being a man is leading to COPD, or men are more likely to have COPD, and so on, because there's much more men than women having COPD. So we we will assume a normal distribution that we compared with. And what we're doing with this first question, what is the chance of observing the value at question, is we'll assuming a null distribution, assuming that it should be 50-50, 50% of men should have this and 50% of women should have this. How far away is 53 from the mean? And is that, and if it's a big, and we ask that because if it's much farther away, it's much less likely to be the case. That is to be expected. So 53% is probably very close to the mean. And we can say that within, let's say, 95% confidence that the the proportion of COPD patients that are men is going to be between, maybe 47 and 53, let's say, for example. It's probably higher than that, actually, maybe 40 to 50. And that's the range of values you could expect, which is also called the confidence interval. And that's a kind of a review of what we did before, and then also what we're going to go over here in more detail. So I really hope we can kind of understand these uh, basic activities where we're getting the chance of observing the value, which is the p-value, and the confidence interval, and also why we're doing this. So I'll see you next time when we talk more specifically about the one mean test.